This is session 62 of quantitative techniques 1 for 5th semester BCom Kuvempu University. So it is about the theoretical distribution, the last chapter of BCom quantitative techniques specialization stream. So we have basically three distributions: binomial distribution, Poisson distribution, normal distribution. Binomial and Poisson distribution are discrete distribution, and normal is continuous distribution. And prerequisite for this is you should have the basics of the binomial distribution. You should know basics of probability and the binomial distribution. Content of this is the Poisson distribution and the calculation of the examples or the calculation of the probability on the same. Objective of the session is to calculate the mean, variance and standard deviation under Poisson distribution and able to solve the problems on the same. Formula for Poisson distribution. In the previous session we have already discussed about the Poisson distribution. So to recall with the formula, P of x equal to e power minus m power x divided by x factorial, where m stands for the mean or NP. E value or exponential value is 2.71820. So the example is like this: 1/5 percentage of blade manufacturing factory turn out to be defective. The blades are supplied in packets of 10. Use Poisson distribution to calculate approximate number of packets containing no defective, one defective respectively, in a consignment of 1 lakh packets. So they have given already the exponential value, that is e to the power minus 0. That is exponential value 0.9802. So that the p value is probability value is 1/5%, that is 1/500. N is 1 lakh and n is 10 packets. Okay, the mean is NP. 10 into 1/500, it is 1/50, that is 0.02. And you will be having a hint in the question also, telling that they will be mentioning the exponential value as 0.02 only. So the values are like this: probability of number of defective, that is x is 0, no defective, e power minus 0.02, 0.02 to the power of 0 divided by 0 factorial is 0.9802. That is e power 0.02 value is 0.9802 only, but 0.02 to the power of 0 is 1. So and 0 factorial value is also 1. So the answer is 0.9802. Probability of one defective, that is x equal to 1, is e power minus 0.02 to the power of 1 divided by 1. So the answer is 0.9802 into 0.02 divided by 1. So the answer is 0.01964. So the expected number of packets with no defective is 0.9802 and 0.9802, which can be multiplied with the number of packets also among 1 lakh packets. The distribution of typing mistake committed. This is another example for the Poisson distribution. The distribution of typing mistakes committed by a typist is as follows. Mistakes are given from 0 to 5 and number of pages are mentioned here. Assuming a Poisson model, find out the expected frequencies. The solution is like this: x value is 0 to 5 and f frequencies are like this, and the total of that is 400. F of x is 0 into 142 is 0, 1 into 156 is 156, 2 into 69 is 138, 3 into 27 is 81, 4 into 5 is 20, 5 into 1 is 5. So the total sigma f of x is 400. So sigma f of x divided by n, that is mean value, is 400 by 400 equal to 1. E power minus 1 is 2.71820 to the power of minus 1. That is e value only, 1 by 2.71820. So it is 0.3679. probability of x equal to, that is for everything till 5 we have to calculate, e power minus m power x divided by x factorial. So it is 0.3679 into 1 power x divided by x factorial. When x is 0, apply to the value of, or the place of x. So the answer is 0.3679, and it must be multiplied with n value to get the output like this. And when x equal to 1, same value or same 1 is to be substituted to the x place, and you are going to get 0.3679 into 400, 147. Likewise for x equal to 2, 0.3679 into 1 square divided by 2 factorial. So 0.3679 divided by 2 into 1, so the answer is 0.1839 into 474. When x is 3, 0.3679 into 1 cube divided by 3 factorial. So the answer is 0.3679 divided by 3 into 2 into 1. So the answer is 0.0613 into 400 equal to 25. So when x equal to 4, 0.3679, 1 to the power of 4 divided by 1 factorial, 4 factorial, 0.3679 into 1 divided by 4 into 3 into 2 into 1. So in a simplified manner, the answer is 0.0153 into 400 equal to 6. When x is 5, it is 0.3679 into 1 to the power of 5 divided by 5 factorial, 0.3679 divided by 5 into 4 into 3 into 2 into 1. So the answer is 1. We have another example. The number of accidents occurring in a city in a day in a Poisson variant with mean of 0.8. Find the probability that on a randomly selected day there are no accidents. So n is 1, that is 1 day. X is 0, that is no accidents, and m is 0.8, which is already given in the problem. Mean value is 0.8. So to solve it, the problem formula is e power minus m power x divided by x factorial. E power 0. minus 0.8, 0.8 to power 0 divided by 0 factorial. So the answer is e power minus 0.8. So it is like this. E power minus 0.8, the answer we can get from the Poisson distribution table, statistical table. So if the problem contains the e power value, exponential value, that should be substituted. If it is not mentioned or if it is not given, the same answer will be kept like that. So the references for this is Quantitative Techniques by C.R. Kothari, Statistics by Jim.com, Coimbatore University previous year question papers. Many of the questions are from Coimbatore University. And Poisson distribution table must be referred to, because there only we can get the exponential values. Thank you.